Hello friend, so far we have discussed about the so many process, that is the non-conventional manufacturing process in the subject of newer machining method. So all the lectures are available on the Engineering College Banswara YouTube channel. So you can refer each and every lecture about this manufacturing process. Then from that you will get the idea about the processes. We have uploaded so many lectures on the YouTube channel of Engineering College Banswara for all the subject, not about the newer machining method, but all the subject with the different branches. So you can refer all the lectures. Today we will discuss about the etching process. Basically, it's a simple step that we have already some portion that we have discussed in the chemical machining. Actually, what is the importance of the etching step? Etching is used in microfabrication to chemically remove layer from the surface of a wafer during manufacturing. So you can study that this process is widely used in the electronics industries, basically for generating this electronically circuit board. Etching is a critical important process module, and every wafer undergoes many etching steps before it is complete. So if we take the simple example, like we have a number of layer and we want to do the etching of all the layer. Now for that it is not possible in manual. It is very simple that you cannot do the etching of each and every wafer manually. For that you need to develop the automated process. So in industries, electronics industry, all the process is done by the robotic arm and the automated system. Nobody can do this manually. It is characterized by the etch rate, etch sensitivity, and etch uniformity. So these are the process parameters that is identify the process. What should be the etching rate and what should be the sensitivity. Now this process is divided into two parts. As per the first one is the wet etching and the second is the dry etching. So etching processes use liquid phase, wet etchant. The wafer can be immersed in the bath of the etchant, which must be agitated to achieve good process control. For instance, a buffered hydrofluoric acid is used commonly to etch silicon dioxide over a silicon substrate. So it's a very simple process. We have also discussed in the chemical machining process that we have a pool of the hydrofluoric acid. Okay, now that pool is used for the etching of the wafer. So therefore and the hydrofluoric acid is in the form of the liquid. So therefore this is known as the wet etching. Now second is the dry etching. Modern VLSI processes avoid wet etching and use plasma etching instead of the wet etching. So each and every process has some limitations. So not a single process is perfect. So in modern industries of the basically it's electronics industry we are discussing about. In modern electronics industry, the people are using the dry etching instead of the wet etching, because the dry etching has many advantage compared with the wet etching. We will discuss in next part. The plasma etching operate between the 0.1 and the 0.5 torr. The plasma produce energetic free radicals and naturally charged that react at the surface of the wafer. Since neutral particles attack the wafer from all angles, and this process is isotropic. So neutrally charged, you can see here, neutrally charged that particle attack on the surfaces. So in dry etching, we have two categories we will discuss. First one is anisotropic and second is the isotropic. So this is the mask. You can see in isotropic, the red color is indicate the mask and the gap that is allowed for the machining or chemical operation. So you can see in both category we are getting the different result. In isotropic we are getting the good curvature and shape, but in isotropic we are not getting the exact shape, because here the etching rate is very slow, so it will take more time to get the solidify. Now some steps that we have to follow in the wet etching: injection of hole into semiconductor to state, attaching charge ohm group to positive charge of silicon, reaction between the hydrostate and the complex agent in the etchant solution, dissolution of the reaction product. Now next one is the dry etching. You can see this is the schematic diagram of the dry etching. Here we have wafers and here we have plasma. So we separated by the upper electrode and the lower electrode and the end wafer holders. Here we are supplying the RF signal and from the insulator. Here we have pump and here we are supplying the gas and diffuser nozzle. So you know that how plasma is generated, that if we heat any gas or air particle around the 25,000 degree temperature, so that will divide into positive and negative charge. So the same plasma is used, and this plasma, as we have discussed in detail in the lecture of the plasma beam machining, so you can refer that lecture. So this is the last part about the dry machining, dry etching. So actually this is a part of the micro machining process. We will discuss a new machining process in the next lecture.